Okay, so not yesterday, but Monday, we did 5.5? No. No. Yesterday, we did 5.5, okay, which was sum and difference formulas. And so today, we are doing double angles, power reducing, half angles, product to sum, and sum to product. Okay, so did you see what happened in our book? This one set took up one section and everything else was crammed into one other section. Okay, so does that kind of tell you probably which ones are used the most?
Yes.
Do you understand what they're doing? You gotta, you know, infer some stuff. You gotta like go, okay, so these probably won't be used as much as the sum and difference ones are. Okay, so these are multiple angle. That's why it's double angle and half angle, all right? And then product to sum. Power reducing, kind of like double angles and stuff, because see, you have multiple angles inside there. All right, so here we go. We're just going to start. Example 1. Okay, so a lot of these skills you already have, but they're just kind of applying them to something using this card. All right, so this one says solve. So as soon as it says solve, I know they're going to give me an equation. Are you with me? And we're going to have to find an x or some variable. So it looks like this: 2 cosine x plus sine 2x equals 0. So there's my equation. Obviously, I'm going to be solving for x. What am I looking for? What does the x represent?
Angle.
An angle, okay? So you're going to be looking for an angle. Y'all were dealing with trig functions. Have you solved trig functions for angles before? Yes, you have. So remember some of those strategies that you learned, okay? Whenever you're solving things like this is what because I'm not, I don't know if it's just because I'm old or what. But anyway, my brain lacks somehow the ability to remember stuff and recall it so fast. So I'm a visual person, and maybe that's more of what's going on, but I'm a very visual learner. So I'm going to write down the stuff that's going to help me when I start talking about my angles. Okay, and I'm just going to do it on the front side. So 1, 0, what are these all called? What kind of angles?
Quadrant.
Quadrant angles. What is going to be my first clue for a quadrant angle? What numbers?
0.
1 and
Zeros and 1. What is the only exception to that rule? Yeah, inverse tangent of a 1. That's a 45. Okay? Now, y'all, is that written in a math book somewhere?
Yes.
No, that's a Billy Gay rule, okay? That's my rule that says, that just helps me. When I see a 0 or a 1, I'm like going, oh, this is a quadrant angle. And then I go, is it a tangent? Because if it is a tangent, it's not a quadrant angle. Okay? So this is 1, 0. What's this guy right here?
0, 1.
0, 1. What's this guy right here?
Negative 1, 0.
And this guy?
0, negative 1.
Perfect. Okay? And then I'm going to go ahead and put that first quadrant in there because really that's all I need. Do you agree?
Mm-hmm.
Okay. So, are you thinking what I'm thinking?
Yes.
This right here is my 45. What is the point? Square root of 2 over 2. Square root of 2 over 2. Okay, so those are the easiest ones to start with because they're easy, all right? So now you've got to start thinking. So we have 2 more. This one's a 30, okay? Remember, a 30 is out farther to the right, so his x is going to be bigger than his y, okay? So what is my point? Perfect, and then 1/2. And now this is a 60, and he's up higher. Then he goes out, so he is what? This guy flipped, yeah, 1/2 and square root of 3 over 2. Now do I have to rely on my memory?
Mm-hmm.
People know, man, I'm just looking up here and finding whatever I need. Are you with me? Okay, so, I'm going to be using these double angle formulas. I'm trying to get them on the screen. Okay, so I'm going to be using these double angle formulas. Okay, so how many double angles do you see in this equation that I gave you?
2. Wait, 4, 0.
Say it, Colton.
1.
1. Y'all, this is not a double angle. This is 2 times the cosine of x. This is a double angle. Do you see that? 2 times an angle, 2 times an angle, 2 times an angle.
I like that. I like that energy, man.
Daily friends.
That was beautiful. Honestly,
Sorry,
I feel
I
like
love
if
that
anybody
song.
ever called me, I'd start crying.
Okay, so this is not a double angle, all right? This one is a double angle. So here's what we're gonna do. Are you with me? Get your mind back on your business, okay? So here's what we're gonna do. We're gonna rewrite this using our formula card. Everybody okay?
Yeah.
Am I gonna rewrite this? Y'all, this is not a double angle. The 2 is not in the same place. Do you understand? This is 2 times something, not the cosine of 2 something. All right? So I'm going to leave this guy alone. Cosine, 2 cosine x. All right? What is sine 2x equal to? See him right here? 2 sine x, cosine x. So this is plus, what's this equal to? 2 sine x, cosine x. All right, is everybody okay so far? Okay, so now it's just exactly, y'all, I would bet if we looked back in our notes, we had worked a problem exactly like this. First period, had no earthly idea what to do. Please, please, please tell me.
I bet Sean knows.
You know what to do. Sean, you be quiet for a second.
Okay, nobody knows.
Yes, another one. Factor.
Jonathan knows.
Okay? Factor. Very good. Jonathan said, let's factor this dude. Okay, so here's the problem. This is what you should be looking at. We have 2 different trig functions. Do you agree? As long as they're together, you can't really do anything with them most of the time. Okay? So yes, that's what we did. We said, can we separate these things? Can we factor something out? What do you see that both terms have that you can take out?
Cosine.
More.
2 cosine.
2 cosine. Very good. So I'm going to take out 2 cosine x.
Wait, the 2 is distributed also to the cosine, right?
It's not distributed, but it's all multiplied. This is just like a 2xy.
That's like the coefficient.
That's exactly right. Okay? It's exactly right. So both of them have a 2 and both of them have a cosine. So we're going to pull it out. So what do I multiply 2 cosine x by to get 2 cosine x? 1. Plus, what do you multiply 2 cosine x by to get 2 sine x cosine x?
2 sine x.
Ah,
Sine x.
very good.
My fault, my fault.
That's okay. Now, remember this, okay? Let me make this clear to you. That factoring is only useful when it's set, when your equation is set equal to what? 0. Okay? So don't be trying to factor something until you've set it equal to 0. Once it is set equal to 0, then when you factor, what do I do with each one of these factors?
Make it equal to 0.
Yeah, set it equal to 0, and then we're going to solve it out. Okay? So I'll have 2 cosine x equals 0, and 1 plus sine x equals 0. Very good. All right, so let's look at this left guy. Okay? We're going to look at this left guy over here. So tell me what to do to solve this thing. Divide by 2. Over here on the left, it cancels out. I'm left with cosine x. Over here on the right, 0 over 2 is 0. Now, as soon as I see this 0 right here, what's my brain thinking?
Inverse
Quadrant angle. So you go in quadrant angle. Punch A and tell him quit saying inverse function.
No, that
I'm
was.
sorry. I know, I was just playing. I was helping Sean out. Okay?
I see where we should.
All right. So I'm thinking quadrant angle. All right? So who is cosine? X or Y? X. So who has an X? Look at your quadrant angles. Do you see why I drew this for you? Okay, but now look, am I going to draw that for you on a test?
No.
No, but you might be wise to draw. Okay, so who has an X value of 0?
This one.
90
2, 7.
Well, let's do radians, people. Pi over 2
2
and
pi over 3.
3 pi over 2.
3 pi over 2, yeah.
3 pi over 2.
That's what we meant.
Okay, so pi over 2, here's my X value of 0 and X value of 0. So pi over 2 and 3 pi over 2. All right, now let's go over here to this guy. Tell me what to do. Subtract 1. So sine x is equal to -1. What's my brain screaming at me? Quadrant angle, quadrant angle. Okay, but what sign, X or Y?
Y.
Y. Who has a Y value of -1?
3 pi over 2.
3 pi over 2.
Wait, so does that mean that's
So, what's my solution? What's my answer?
3 pi over 2?
And,
Pi over 2.
yeah, it's this guy, pi over 2,
Uh,
3 pi over 2, and we've already got a 3 pi over 2. It's redundant to list it twice. That's silly. All right, is everybody okay?
Yes.
All right, so let's do the next one. This is example 3. I skipped 2, sorry. I don't know why my brain was going 5. Okay, so I skipped 2, don't worry about it. Obviously, I didn't like it, so we're not doing it. So example 3. Find, oh, you're gonna like this. This is cool.
I really don't.
Okay, and this is an easy one. I didn't think this one was too bad. Did you think this one was too bad?
yeah.
Not too bad. This one's not gonna be too bad. Then they get a little messy,
Oh, great.
okay? A little messy. All right, but y'all listen to me. It's gonna be okay, all right? I'm gonna take care of you. It's gonna be okay. If you just do what I ask you to do, you're going to be okay, all right? I'm gonna ask you to practice some of them. Can you sit out there and stare at them and go, I don't know what to do? You can't. You gotta do something, all right? So we're gonna find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta, given that the cosine of theta is equal to 5/13 and theta is greater than 3 pi over 2 and less than 2 pi.
Wait, is that supposed to be tan?
This is tan.
It just looks like TA.
No, it's tan. All right, so look, here's the first thing that I see. Do I have a formula for sine 2 theta, cosine 2 theta, tangent 2 theta? Yes?
Yes.
Look, here they are. Those are double angles, guys. So, sine 2 theta, cosine 2, oh, what? Cosine 2 theta has like 3 of them. So we could pick whichever one we wanted to. Do you agree? Okay, and then there's the one for tangent 2 theta. Okay, so, can you draw a picture of theta? Do it, you have 10 seconds. Draw a picture. Draw a picture of theta. If I tell you this right here and you can't draw a picture, you're way behind, people. You're way behind. You ought to know where it is, and you ought to be able to find every one of its sides.
I was about to ask lowercase or uppercase.
Yeah, me too, that's why I thought.
Lowercase or uppercase?
We just learned the
Greek
Greek alphabet.
alphabet.
Oh, I was like going, what are y'all talking about? I didn't get it, sorry. Okay, so everybody got it? What quadrant am I in?
4.
4. How did you know that? Yeah, it says it's greater than 3 pi over 2 and less than 2 pi. So that's quadrant 4, people. All right, so I'll draw him in quadrant 4. Was that hard?
No.
That's theta. Then I said, put all the sides where they belong. They gave you the cosine. Cosine is adjacent over hypotenuse. Remember when that used to be hard for y'all? Remember when you were like, oh my gosh, what? Tell me. All right, so adjacent is 5 and hypotenuse is 13. It's a Pythagorean triple, guys. Tell me what this side is. And specifically it is -12, right? Because it's going down. All right, everybody okay so far? Is this all stuff you should have been able to do? Now, this was on your last test, identities test. Okay, it's the same exact thing. All right, so let's do this. Let's do this guy first. Sine 2 theta. Okay, sine 2 theta. What does our formula card say? What's sine 2 theta equal to? I'm looking at my formula card. Here it is right here. Sine 2 theta is equal to 2 times the sine of theta, cosine of theta.
Yeah.
This is easy, people. 2 times the sine of theta, the cosine of theta. What would make it difficult if I said, we're not using our card on our test? Okay? I'm not saying that. So it's equal to 2 times. Can you find the sine of theta? People, there's a dang triangle over here. Sine, oh heck, opposite over hypotenuse. -12 over 13. Are you okay? Cosine of theta, adjacent over hypotenuse, 5 over 13. Am I going too fast?
A little bit.
A little bit? Okay, so I'll try to go a little bit.
Like, I know what you're saying, it's just
I
I
know,
can't write it
but,
down.
okay, so, yeah, and here's what happens, okay? So, understand this, when you're taking notes, if you're not working ahead of me a little bit, then all you're doing is copying off of me, and you're not really learning anything. Do you understand what I'm saying? So the object of the game, huh?
You go at 1,000,000 miles an hour.
Well, I just said, that's why I asked him, am I going too fast? And so, one person said a little bit, okay? So I slowed down. Did I just give you time to work that problem?
Yeah.
All right, so here we go. I'm gonna multiply all these. When you have one negative, what do you know about your answer? He's negative. Top times top. So I'm gonna multiply the 2 times the 5. I always try to make something that ends in a 0. It's easier to multiply. 2 times 5 is 10. What's 10 times 12?
Negative 120.
All right. On the bottom, 13 times 13 is?
169.
Here's my answer. Was that hard? No, that's not hard.
Some.
That's it. So all I did, I used my formula card and I found it. What's the next thing I'm fixing to find? Cosine 2 theta. Let's find it. Cosine 2 theta is equal to, yes?
Do we have to reduce the fraction?
It won't reduce. Okay? He won't reduce.
Wait.
Sean, believe me?
Sean had to check your
Oh,
math.
I had to check my math. Okay, so he doesn't reduce. All right, so let's do the cosine of 2 theta. So I'll look over here, okay? Can I choose any of those?
Yes.
Yes, you can, okay? So tell me why I'm going to, you don't have to if you don't want to, okay? But tell me why I'm going to use 2 cosine squared minus 1.
Because we would get.
Yeah, because y'all, it gives you cosine. Can I mess this one up?
No.
If I got this sign wrong accidentally, then I'm still gonna get this one answer right. I may miss everything else, but I'm gonna get this one, okay? So that's why I choose that one, but you don't have to, you can choose any one that you want to. So 2 cosine squared theta minus 1. Well, that is 2 times. What is the cosine of theta? People had told it to me, 5/13. You should be working ahead. 5 over 13 squared minus 1. Order of operations. I'm trying to slow down, okay? Order of operations says, what do I have to do first?
Exponents.
Exponents. So how do you square a fraction?
Top
Square the top, square the bottom. What's 5 squared?
25.
13 squared.
169.
Now what do I have to do?
Multiply.
Multiply. Put this guy over 1. Obviously 2 does not reduce into 169. Okay? So I have to multiply the top. 2 times 25 is 50. And the bottom, 1 times 169 is 169. Minus. I'm going to need me a common denominator. Is it fast and easy to find one right now?
Yeah.
People, this is 1. Okay? I can put something over itself and always be 1. So what am I going to put?
169.
Very good. 169 over 169. What is 50 minus 169?
119.
Negative 119 over 169. That doesn't reduce either.
Will it always not reduce?
No. All right, everybody okay?
Yes.
Okay, so this is the tangent. The tangent one is generally the most difficult one. So here's the only, okay, listen to me. Can you leave a radical in the denominator?
Yes.
Yes. In trig, it is legal to leave a radical in the denominator. Let me ask you this. Can you leave a fraction within a fraction?
No.
Y'all, that is not legal. Okay? That's not legal in trig and it's not legal in algebra. So that would be our only problem that we would have to address. The radicals are not a big deal. Okay, so here's the formula for tangent. Tangent of 2 theta is equal to 2 times the tan of theta over 1 minus tan squared theta. All right, are you with me? You should be working ahead. You should already have your numbers filled in. So 2 times tangent, opposite over adjacent, negative 12 over 5, over 1 minus, Well, obviously, it's negative 12 fifths squared. Okay, I'm gonna try to work down my page a little bit, because I don't have enough room to work out. I may have to go out once, but we'll see. Okay, so this becomes, over here, I'm gonna multiply top times top and bottom times bottom. If you need to, stick that little 2 over a 1. All right, obviously it's gonna be negative 2 times 12 is 24 over 5, all over. Okay, let's square this guy right here. When you square that negative, what is he gonna become?
Positive.
Positive. So that's gonna be 1 minus 12 squared is 144, 5 squared is 25. Are you with me? Can I flip it and multiply? No. You cannot flip them. Y'all, this is a complex fraction. You studied these in Algebra 2. We're gonna study them again this year, next semester. All right? But, because some of you didn't get them in Algebra 2. All right? And I know because I graded your paper. All right, so you cannot flip and multiply until you have one term on the top and one term on the bottom. So we have to collect these two down here. My top is good, negative 24 over 5. Down here, what am I gonna get? 25, you're gonna get, look, you're gonna get 25 over 25 minus 144 over 25. Tell me what that is. Negative 119 over 25. Okay, now can I flip and multiply?
Yes.
Okay, so now I'm gonna flip this guy on the bottom, 20, he is negative, so 25 over 119. Can I reduce?
Yes.
Y'all always look to see if you can reduce. It makes your answer so, your problem so much easier. How many times does 5 go into 25?
Once.
Okay, now can I multiply 5 times 24?
Oh, I just said 25, 25, that's not bad.
Okay, so a negative times a negative is a positive, so I'm gonna know my answer is positive. Are you with me? Okay, on the top, I get 5 times 24. Watch how I can do this without a calculator. What's 5 times 4? 20, carry your 2. What's 5 times 2? 10 plus 2 is, you don't need a calculator, people, come on. What's 1 times 119?
119.
So there's my answer. Okay, now watch this. Now, first of all, before I show you this, let me make sure you understand. This work is what I'm looking for. This, what I'm fixing to show you is a check. Okay, this is a check. Is tangent sine over cosine? Sine over cosine. Whoa, that's pretty cool though, isn't it? All right, sine over cosine. Now, if I was taking the SAT test and they told me the sine and the cosine and asked for the tangent, would I be doing all this mess right here?
No.
People, I'd be slapping out that answer. Your denominators are the same, so they go away. It is negative 120 over negative 119, which makes a positive 120. All right, everybody okay so far? That's pretty easy. Do you agree? Okay. So let's go on. Now, what did I say was fixing to happen? They're gonna get a little crazy. All right? They're gonna get a little crazy. All right? So, here we go. Example 4. They want me to find the sine of 3x. Okay? Now, obviously, am I gonna get it down to a number?
Yes. No,
Why?
because it's sine. 3x, x,
You
variable.
got an x in it, people, and you don't know what it's equal to. You can't solve for x, okay? So I just wanna see if I can find out what this is, okay? Do you have anything on your formula card that has a sign of 3 times u or v or something like that, which is what all the formulas use?
No.
No, you don't, do you? Okay? So, I need to rewrite this. Anybody know how we're gonna rewrite it? What? Very good. John Paul says, what? We can do this. X plus 2x. Is this a sum? This is a double angle, but we have double angle formulas, don't we? All right, so we're good to go. Anybody got a question? No? Okay, so here we go. So we're looking at the sum, sine of something plus something. So here it is. The very first formula on your card, sine of u plus v. all right? So it's gonna be sine of the first, cosine of the second, plus cosine of the first, sine of the second. You with me?
Mm-hmm.
All right, so here we go, let's rewrite it. It is sine of the first, cosine of the second, plus cosine of the first, sine of the second. Now do you see something that we have a formula for that we could simplify it out better? Yes, those are those double angle formulas, okay? These are my double angle formulas, so I need to do those, okay? Now I'm gonna tell you this, when you do this one right here, you're gonna go, I don't really know, because there's three to choose from, do you agree? That's the only reason that I think this problem is really difficult, because you look at that and you kinda go, I don't really know which one to use. Okay, so y'all listen to me. As you get down the problem, there's 1,000 different ways to work it. Okay, I mean I'm going to obviously show you the best one to use, but you might not have chosen that one, and you might need to go a different route. It would be okay. All right. So this is what I did. I rewrote this one first to see how I might like to rewrite this one. They didn't give us any directions here, but I'm going to do this. I'm going to try to write it all in terms of one thing, all in terms of one thing. And they might tell you that on some of them. Some, as we get later on, they will tell us that kind of stuff, but right now they haven't. So I'm going to rewrite this guy. So he's cosine x times, what is sine 2x? Do you see? 2 sine x cosine x. So 2 sine x cosine x. Okay, are you with me?
Wait,
All right.
wait, where are they on here?
Where is it on here? Right here.
The double angle.
Oh, yeah.
Double angle. Okay, so now, watch what I'm fixing to do. I'm still like unsure because I still have sines and cosines, so I'm still kind of unsure which one I might want to pick. Okay? So I'm going to go ahead and multiply this together. Tell me what you get when you multiply it together. 2 sine x, what?
Cosine squared.
Cosine squared x. Okay?
Did
Now,
you just skip a step?
nope. Y'all look, you're not distributing that.
Oh.
Do you understand? There's no plus sign or minus sign. That's a common mistake, okay? But you have to be really careful. You only distribute across a plus or a minus sign. All right, so this is just all multiplied, like x times y times z, with a 2 stuck in there. So it's 2x, y, z, but these are 2 the same, so we square it. All right? Now, here's what I see now. I see now that I can put this in terms of sine. Do you agree with me?
Yes.
So now, I'm going to go back up here, and then when I use my cosine, I'm going to do the one that has a sine squared in it. Because this is going to be a sine, I can turn this into a sine squared.
Wait, how are you gonna
Okay?
turn it into
Now
a
y'all listen to me. This is what I'm going to tell you. When you first start working these problems, you're not going to see that kind of stuff. Okay? But even if you did the wrong one, you could come back around to the answer. They're kind of like those trig identities. You know, you might not all do it the same way, but you're all probably going to get down to the same answer.
Why
Now,
would you not use the cosine squared one? Like, why are you using sine squared?
because this cosine squared, because I don't have any, I can't write this sign in terms of cosine. Do you see what I'm saying? I can't write this in terms of cosine. I don't have anything that lets me do that. But I can write this. Do you agree that I can write this as 1 minus sine squared? Now, what's the only function that I have? Right here, sines. So I'm gonna see if I can write all sines right here. That's
Miss
what made
Davis?
me do it. Yes, ma'am?
I need Viola to come up front to lead, please.
Okay,
Thank you.
you're welcome. All right, so this is sine x times. Y'all be sure and put this in parentheses because you are fixing to distribute something here. Cosine, here he is right here. Which one am I gonna use? Am I gonna use the first one? No, because it has a cosine squared. Am I gonna use the second one?
Yeah.
Obviously no, because it has a cosine squared. I'm using the third one. Why? Because all he has are sines. So 1 minus 2 sine squared x. Okay, so now, can you distribute here and here? Are you with me?
Oh wait. Oh.
What's sine x times 1? What's sine x times 2 sine squared? 2 sine what? Cubed. Yes, 2 sine cubed. Okay? And when you get this, it's kind of scary, right? Because you're like going, what? Sine cubed? But y'all look. Look down here. When I distribute here, what are you going to get?
The same thing.
The same thing. So I'm like, okay, maybe I'm on the right track. All right, so I'm going to write this down. Okay, so now I'm going to distribute over here. Sine x minus 2 sine cubed x plus, you're just manipulating an equation, all right? That's all you're doing. What is 2 sine x times 1?
This is on X.
What is 2 sine x times sine squared x?
2 sine cubed.
2 sine cubed x. All right, people,
Damn.
here we are. You see any like terms?
Yes.
Yes. What is sine x plus 2 sine
3
x?
sine X.
What is negative 2 sine cubed and negative 2 sine cubed?
Minus 4
4
sine
sine
cubed.
cubed.
So that is how you would find sine of 3x. That would be a formula, a nice formula.
It's not that hard to like.
Huh?
That whole thing is nasty.
It is a little bit nasty, okay? I mean, this is remember what I just said to you, okay? These that we just did, examples 1, 2, and 3, are they bad, or 1 and 3, are they bad? No. What's bad about this one? You don't really know where you're going. That's what's bad about it, okay? All right, let's keep going. Example 5. Here's what it's going to say. Now, this one is going to be kind of like this one, but you're going to like it better. Why? Because it's going to give you some direction, okay? It says rewrite sine to the 4th x as a sum of first powers of cosines of multiple angles. Okay? So,
Wait, can you stop?
yep, I am. I'm just writing that. All right, so here's what we got. First of all, can I have any squares or cubes or 4th degrees? No, he says first powers is all I can have, okay? What's the only trig function I can have?
Cosine.
Cosine. He didn't say any other trig functions. But I can't have multiple angles, do you understand? So I can't have like 2x's or 3x's or 4x's or anything like that. He just says, I want first powers, I can only have cosines, and I can have multiple angles. Probably going to have multiple angles. All right, so first of all, this is sine to the 4th. Do you have any 4th degrees on your card?
No.
No. So do you agree we're probably going to be doing power reducing, right? I only have a square. So could I write this as a square? How?
Sine squared.
There you go. Square. Do you agree with that? Are you with me? Okay. So all I'm doing is manipulating it around this card. Okay? Then I can find this. Can you find this right here on your card? See him right there? So I'm putting this in his place. Now look at what's happening. We went from a sine function and now where are we? A cosine function of a multiple angle. That's okay. All right? So we're going to put this in this blue line's place. And we'll have to square it. So equals 1 minus cosine 2x over 2, quantity squared. Now what's gonna make this guy bad is we're gonna be using some algebra skills, okay? So, here we go. So when I square this, can I just square the denominator first? Okay. So, remember how to square a binomial? My kids, my algebra kids just learned it today. They thought it was the coolest thing they ever seen. They're like, what? Why didn't they teach us that last year? Here we go. Square the first. What is it? Keep the sign. Twice their product. These two things right here multiply to be cosine 2x. What's twice that?
2 cosine.
2 cosine 2x. So square the first, keep the sign, twice their product, plus square the last. What is it?
Cosine 4x?
No,
Cosine 2x?
cosine, yes. That's all it is.
It's cosine 2x squared.
Yes.
Are we sure?
Yes, that's all it is.
Okay.
Yes. Cosine squared 2x. Okay? I was checking to make sure.
Oh, so it's not.
I thought it was. No.
Wait.
Look, what are you y'all look, what are you squaring? You're squaring this. Are you gonna go inside it and square it again? Or multiply by 2? No, you're just squaring it. So that's what you're doing. Alright, so I'm gonna rewrite this a little weird way, okay? This guy down here kind of bothers me, so I'm just gonna pull him out front. You see what I did? I just got rid of this, okay? And here's why I got rid of it. Because this guy is the only problem that's not following the rules. Do you agree? He's legal, he's cosine, he's multiple angles, I'm good with him. This guy's not legal, so we're gonna have to rewrite him, all right? So obviously, I'm using a power reducing, so here he is, okay? So what's fixing to happen is I'm fixing to make another fraction. I didn't wanna make a fraction on top of a fraction, so I just cheated and pulled this guy out, okay? So here, I just have a 1, right? Minus 2 cosine 2x plus, now I have to rewrite this guy.
1.
Are you with me? I'm rewriting this guy right here, right here.
4.
So, what is he? Here's the formula right here. He is 1 minus,
Wait.
I don't understand.
That's plus.
oh, sorry, plus, sorry. 1 plus,
Cosine 4x.
okay? Are you with me?
Oh, yeah, I get it now.
I'm using this formula right here to rewrite this cosine squared,
Yeah.
okay? I'm using that formula. What's that number?
1.
So write it down, 1. What's that sign?
Plus.
Plus, okay? So what's that word?
Cosine.
Cosine. Now it says 2. This is a U, people, and this says 2 times that angle. So what's this gonna be?
2x.
What? What is 2 times that angle?
2x.
I guess 4.
Yes.
Oh. What?
Do you see what I'm saying? Look at your formula, people. This is a 1U and this is a 2 times that. So this is a 2x, so when I multiply 2 by it, I get 4x.
So if it,
Are you with me?
if it was just you, it would have just been
Yes.
six.
If it were just an x, it would have been a 2x. But it was a 2x already, so when I doubled it, it became a 4x. All over what?
2.
2.
I wanted to say 2A.
Okay, so here's my deal. Is everybody legal now?
Yeah.
Yes. So all I'm gonna do is clean it up, okay? This is my answer, but it's not pretty and it's not clean. We need to clean it up.
Would it be acceptable?
No, I would take points away just for not cleaning it up. Okay, so watch what I'm fixing to do. Are you ready? Are you ready? Let's see, should I do, I think before I distribute that, I think I'm gonna separate these guys. Can I separate that top? I think it'll be easier for some of y'all to see. So I'm gonna leave this little 1/4 out here. 1 minus 2 cosine 2x. What does this become? Separate it. Can I separate a numerator? Yes. What can you not separate?
Denominator.
Denominator. What does this become? 1/2 plus cosine 4x over 2. All right, let's make sure we understand this. Can I reduce this 2 and this 4?
No.
No, y'all, that's part of that angle. You cannot reduce that. Okay? Now I'm gonna distribute my 1/4. What's 1/4 times 1? 1/4 times 2, that's 2 fours, or what?
1/2.
1/2. What's 1/4 times 1/2? 1/8. Look here. What happens? This becomes that over 8. Do you agree? Can I write it like this? 1/8 cosine 4x?
Yes.
Yes?
Whoa.
Same thing.
Oh,
I know, I
Oh,
kinda
wait, never mind. No.
jostled you a little bit.
so wait, why is the,
Cause I just pulled it out and this is the same thing, this right here is the same thing as 1/2 cosine 4x.
Do we use a calculator?
Okay? Well, so far I haven't needed one.
Well, I
well,
have.
that's here.
But like sure.
So what about these guys?
Yep.
Can I collect those? 1/4 plus 1/8, sorry about that. Put it over 8, multiply times 2 times 2. 2 plus 1. So these two collect to be 3/8. Can I collect these two? No, they are not like terms.
Wait,
Where'd you get
3/8.
the 3/8 from?
1/4 plus 1/8, right here, I did my work.
Wait, whoa.
Why wouldn't you do that? Oh, wait a minute.
These are not the same, because it's a 2x and that's a 4x.
What happened to the two, like after you multiplied a fourth and a half, that 2 on the bottom?
Right here? Okay, so do you agree that this right here is the same as this right here? Okay, so I just multiplied the 4 times the 1/2 and it became 1/8. Okay? Alright, is the bell fixing to ring?
Yes.
Okay, so we're not gonna get to the next problem, so we'll have to do it tomorrow. So tomorrow I'll work some, and then we're gonna practice Thursday and Friday, and we're gonna test Monday and Tuesday. Okay? We're gonna test Monday and Tuesday. Alright, is everybody okay?
That's gonna be our last.
It's gonna be your last grade. Last grade for the 6 weeks.
GG.
I'm gonna be doing it. I'm feeling it. I feel it.
Right now,
I don't know.